Hey everyone, today we're looking at the paper Answering Complex Open Domain Questions with Multi-Hop Dense Retrieval by authors from Facebook AI and University of California, Santa Barbara. This paper is about open domain question answering, where the goal is to be able to answer general open domain questions such as what was the nickname of Judy Lewis's father, where Judy Lewis is an actress. Answering such general questions requires to have some sort of a database or knowledge base at hand, such as all articles on Wikipedia, because you need to be able to have the knowledge to answer this question. And these types of questions in particular are very difficult because they require not only having a single supporting article to answer the question, but multiple articles. So in this case, you need a paragraph talking about the actress that has a father who is Clark Gable, and then you need to have another paragraph talking about Clark Gable, that his nickname was the King of Hollywood, which is the correct answer of this question. So you need to not only have a single paragraph about the actress, that's not sufficient, but potentially a sequence of paragraphs which all come together and complement each other to come to the final answer. And so the authors focus on this problem specifically of retrieving a good sequence of paragraphs that complement each other to come to the answer. The way this works is they propose a novel recurrent model which sequentially performs information retrieval to return new paragraphs which complement the previously retrieved paragraphs. The model is consisting of a question encoder which encodes the question as well as all previously extracted paragraphs. And also there's a dense corpus index which contains paragraph embeddings of all paragraphs in your database, which could be, for example, all paragraphs from Wikipedia. And the way it works, at the first step, you are computing a dense query vector, so-called, only from the question. And for the encoder, they're using a Roberta-style encoder, and they apply the same encoder to paragraphs and to questions. So you get this dense query vector, and you use it to get the best paragraph from the dense corpus index, so paragraph 1. And then for the second step, you're actually going to be inputting the first paragraph to the question encoder as well to get a second dense query vector, which is combining the information already extracted with the question to get other paragraphs that are also relevant and complement paragraph 1 the best. So you get your second dense query vector and you get paragraph 2 then. And you can keep doing this in theory forever as long as you want, depending on how much computational time you want to sacrifice, but also how many paragraphs you think are needed to answer the questions. And the authors in this paper focus only on extracting up to 2 paragraphs because the datasets that they're working with require extracting up to 2 paragraphs, basically. But this can be extended to more paragraphs. So their approach seems to be very effective for this paragraph retrieval task, achieving 28% relative gain in terms of recall on the HotpotQA dataset, which is a dataset based on Wikipedia. Basically, you are provided an open-ended question and also some paragraphs which are containing the supporting information to answer the question. And also you're provided with an answer, and the task is to come up with the answer. So on this dataset, you're getting, first of all, high recall, but also the authors show in the results section that also the retrieved articles lead to a better performance when you actually have to generate the final answer or extract the final answer. So the retrieved articles improve downstream performance for the retrieval. They also test the model on another dataset called Fever, which is multi-evidence retrieval to support some facts. And overall this model seems to be pretty effective for this multi-step retrieval task. The authors also propose a re-ranking method to improve the retrieval performance even more. What the re-ranking is doing is not only, so after you retrieve some paragraph candidates at each step, the re-ranking is doing some additional step to reorder the top K retrieval candidates, let's say the top 10, so to get paragraph 1. you're going to be getting your top 10 candidates from the dense corpus index. And then you can apply a re-ranking method to resort those top 10 candidates using a more complicated model, which again is going to do another step of comparison to get to better paragraphs. So this re-ranking method is also effective for this method. And yeah, so in overall seems to be effective way. So this recursive retrieval approach seems to be effective and improves open-ended question answering as well, while being 10x faster at inference time. So interesting paper, and I would encourage you to take a look for some more details and precise examples and comparisons to a wide range of methods on these two tasks. Thanks for listening, and I'll talk to you next time.